This is a new topic, 5-1 ratios. And this is page number 44. So turn to page 44 in your guided notebook, page number 44. So a ratio is just an equivalent fraction. So if you know how to multiply your numerator and denominator by the same number and divide your numerator and denominator by the same number, learn a little bit of ratio language and the different types of ways to write ratios, you should be good to go. So the objectives of this lesson is to use ratio language to describe the relationship between two quantities. We want to write ratios in 5 different ways. Now, the Louisiana Standard focus on 3 ways, but why not just talk about it in all 5 ways right now? And some important vocabulary words, grab your highlighter. What is a ratio? A ratio shows the relationship between two quantities, x and y. So let's say we have 5 boys in the class and 6 girls in the class. So the ratio of boys and girls will be 5 to 6. So you have to make sure you put ratios in the correct order. That's one of the most important things. Order is important. I actually want you to write that down. Order is important. For ratios, order is important. The next word is quantities. So highlight that. The amount of a number of material or immaterial. So that's important. And then we want to know what a bar diagram is, another way to represent ratios that show how two quantities are different, have different, and different units are related. So two quantities in different units are related. So we're going to look at an example of that, which is right here. So this is a bar diagram. The ratio of cups to plates is 2 to 4. So this is going to be cups, and this is plates. So remember that we wrote order is important. So the 2 is going to go with the cups because that's the numerator, and then the 4 is going to go with the denominator, the plates. So if you want to use a bar diagram, you will draw 2 rectangles for your cups, 1, 2, because the ratio is 2 to 4. And then you will draw 4 rectangles to represent the plates. So here you can see for every 2 cups there are 4 plates. And you have to make sure that ratio is consistent. So if you double the ratio, you will have 4 cups and 8 plates. Another way to model is using a double number line. That's another way to represent ratios that uses length to show how 2 different quantities are related. So we're going to highlight that double number line, and here's an example right here. So we have the same exact, well, we changed the ratio, so now the ratio is going to be plates to cups. So now since the plates is first, this is going to go with the 4, because when the ratio is written 4 to 2, the 4 comes first. So you're going to have plates, and then the 2 is the colon, and then the cups. So the 2 is for the cups. So order is important when you're talking about a fraction. It's the numerator, denominator. This 2 is like the fraction line. And then down here is the first term in front of the colon, 2, that's the colon, the second number. So we're going to look at different ways to write ratios. Plates, we have 4 plates to 2 cups. So if we were to divide both the numerator and denominator by 2, or both numbers by 2, we'll get an equivalent ratio, which is 2 to 1. And then if we were to multiply the simplified ratio by 4, we'll get 8 to 4. So this is the same ratio as this one up here, but the order is different. So they're related, but different, because order is important. All right, so a ratio is a relationship in which for every x unit of one quantity, there are y units of another quantity. The quantities x and y are the terms of the ratios. So ratio is our vocabulary word here. So right here we have a picture shown of red circles and blue squares. So you use ratios to make a comparison. So we can compare these shapes using ratios. The ratio of the number of the squares to the number of circles is 4 to 3. So notice here that it said squares to circles. So the squares is going to go with the first term of the ratio, which is the 4. And then 2 is obviously the same 2 that's here. And then the second one is going to be circles. Remember, order is important. You can also write this as 4 colon. So there are different ways you can write ratios. You can use a colon, you can use 2, or you can write it as a fraction. And we'll also learn that you can write it as a decimal, because if you can write it as a fraction, you can write it as a decimal. And if you can write it as a decimal, you can write it as a percent. So let's just look at this right here. So it says sometimes you compare the two parts. So what are the parts? What is a part? A part is something that makes up a whole. This part is made up of circles and squares. And the whole is obviously going to be shapes. What do they have in common? They are both shapes. So a part out of a part-to-part ratio is going to compare two parts. So we have 4 blank to 3 blank. So we have 1, 2, 3, 4 squares. So go ahead and write 4 squares to 3. So we have 1, 2, 3 circles. So we will write the ratio is 4 to 3. You could also say 3 circles to 4 squares. So this is a part-to-part ratio. This is example of part-to-part. So we're going to come over to the other side over here. And it says sometimes you can compare the part and the whole. So the part will be the part, which is the square or the rectangle, to the whole, the total number of shapes. So we have 4. So see, we have 4 squares to a total of 7, because we have 1, 2, 3, 4, 5, 6, 7 total shapes. So a total of 7 shapes. And this is called a part to whole ratio. This is called a part. I want you to write that down. Part to whole ratio. And over here, this one is called a part to part ratio. Really important for you to know the difference. So in your guided notebook on this page, which is page number 44, I need you to cross off this 5 and I need you to put a 4, because there are 4 squares if we count the squares. 2, 3, 4 squares to all shapes, and all shapes is going to be 7. So this is so what I want you to add here is that this is a ratio of squares to circles. So this is the ratio for squares to circles. And remember, order is important, so you have to put the number of squares, the number for squares with the squares, and the number for circles with the circles. So some ratio language that you can use. This is one of the important objectives. You can also use phrases like for each or for every. So highlight those. Those are really important phrases that you definitely want to know, because those do come up in word problems. So terms like for each or for every. To describe ratios, for example, you can say 3 circles for every 4 squares, or you can say 3 circles for each set of 4 squares. So to write a ratio, you can use the words to, you can use a colon, or you can use a fraction bar. If you can write it as a fraction, you can also write it as a decimal, and we will also learn that if you can write it as a decimal, you can write it as a percent. So turn to page 45. All right. And we're going to complete this chart. And make sure you're paying attention, because you're going to have to answer some of these on your own. So we have a part-to-part ratios. So we have part-to-part ratios. So a part was the circles to the squares. These are 2 parts. So we can write it as 3. You could also use a colon, so you will write it in the same order. 3 colon 4, 3 to 4, 3 colon 4, You could also write it as a fraction. The 3 is the numerator, and then the 4 is the denominator. And if you were to divide it, so standard long division, drop the top number in, 3 divided by 4, 4 goes into 3. 0 times 4 is 0. We subtract. We have to add a decimal point. Add a decimal point right above it in the dividend or in the quotient. Add a 0, bring it down. 4 goes into 30. 7 times 4 is 28. And we have 2 left over. Add another 0 in the dividend, bring it down. 4 goes into 25 times. So 75 hundredths is equivalent to 3/4. It's equivalent to 3:4, and it's equivalent to 3/4. And if we wanted to write that as a percent, percent is just a fancy way to write per 100. So percent is a fancy way to write per 100. So since we have 75 hundredths, you can write that as 75 hundredths, but instead of writing it as a fraction, you would just write 75 percent, 75%. So if you can write it as a decimal, you can definitely write it as a fraction as well. So now let's look at this next type of ratio, part to part. So this one is going to compare squares to circles. So the number that's associated with squares is 4, and the number that's associated with circles is 3. So you have to make sure you put it in that order. The 4 squares first, and then the 2, the colon, the fraction line, or whatever, that next. And then your other ratio. So we have 4 squares, so we put the 4 first, and then we put 2, and then we put the 3 to represent the circles. So notice this is squares to circles. It has to go in the same order. If it's not in the correct order, it is incorrect. So now we write it as with a colon, squares, colon, circles, squares to circles. And then if we wanted to write it as a fraction, how would we write that as a fraction? We would write 4/3. And then if we wanted to change that into a decimal, standard long division, drop the top number in. So that means we would have 4 inside of the house and 3 outside of the house. Notice that this is a improper fraction, so we should have a whole number in front of a decimal point. So 3 goes into 4 one whole time. 3 times 1 is 3. We subtract, we get 1 left over. Now we add a decimal point and a dividend. Before you add zeros, you have to put a decimal point. Bring that decimal point right above it in the quotient. And now we can add a 0 and bring it down. 3 goes into 10 3 times. And 3 times 3 is 9. I subtract, I get 1 more, add a 0, bring it down. What is that vocabulary word that I need to put here? Who remembers that vocabulary word? We put that vinculum line above that last number, so I can write this as 1 point, or 1 and with a 3, 1 decimal point 3 with a vinculum line. And if you could write it as a decimal, you can write it as a fraction, or if you can write it as a decimal, you can write it as a percent. So it would be 1 and 33 hundredths. So this is a percent that's higher than 100. So what you can do is you will write 1 and 33 hundredths. So that's just another way to write percent. So I can get rid of the per 100 and put 133%. Or you could just multiply this decimal point times 100, and it'll give you the percent. So to go from decimal to percent, you can multiply by 100, or you can remember percent is just another way to write per 100. All right, moving on to the next one. We have a part, and you don't need to write the decimal examples down, just fill in the chart. We have a part to whole ratio. So we're starting with a part, and we have a colon, we have our 2, we have our fraction line or whatever, and then we put the whole. So circles needs to go first, order is important, and then we need to put the total number of shapes. So the part that represents the circles is 3, and then this is our 2 count, so we're going to put 3, 2, because this is where we're using 2s for this set. And then the total number of shapes was 7. So this is the ratio for part to whole, a part to whole ratio for circles to shapes. So write that using a colon, we will write 3:7. And then we have 3/7. Remember, order is important. The 3 and then the 7. And then if we change that into a decimal, we'll get this number here. And if you could write it as a decimal, you can write it as a percent. So I'm just going to move this decimal point 2 times to the right. And my percent is going to be 42 and 86/100%. So the next set is a part to whole ratio. And we're going to be comparing the number of squares to the number of shapes. So the squares was a part because we had 4 squares, and the total number of shapes was the whole. So this is a part to whole ratio. So we will write 4 to 7. And then to write it as with the colon, you will write 4 to 7. And how do we write that as a fraction? Remember, order is important. So you will write 4 over 7. And we already have it as a fraction, or we already have it as a decimal, and we have it as a percent. Notice that the difference between the percent and the decimal is just moving the decimal point 2 times to the right. All right, then we have whole to part. So that means the whole will go first and then the part will go second. So this is the total number of shapes, to the total number of squares. So we have a total of 7 shapes, and then we need to use the word 2. And then we will put the 3 to represent the number of circles. And we already have it using the colon. Notice that the 7 goes first when we write it with the colon. The 7 is the numerator when we write it as a fraction. And then when we change it into a decimal, we have 2, and then we have 3, and the 3 repeats. 2 and the 3/10, and the 3 repeats because we have the dots there. So if we wanted to change that to a decimal, we literally will just move the decimal point 2 times to the right and change it to a percent. But instead of putting a 0 right there, since the 3 repeats, you will have a 3 right there. So I'm going to put 233%. And I'm not going to put the dots and keep going forever. 233%. So whole to part is the last type of ratio here. Whole to part. So this is going to be the shapes, the total number of shapes to circles. So we have 7 to 4 because 7 is represented by the total number of shapes. And then we have 2. So different ways to write ratios. And then we have squares. And since we have 4 squares, we put a 4 in that spot. So if we wanted to write it with the colon symbol, we put 7:4. If we want to write it as a fraction, we will write 7 over 4. And to write that as a decimal, you would divide, and we should get a proper fraction. So we'll have 7 in the house, standard long division, drop the top number in. 7 divided by 4. 4 goes into 7. 1 times 4 is 4. We have 3 left over. And I'm going to add, well, 3/4. I know 3/4 is 3 out of 4 quarters, so that's 7/500. So I'm going to put 1 and 7/500 because it's 75 cents. 3 quarters in a dollar, 75 cents. All right, and if I wanted to change that to a percent, I could just move my decimal point 2 times to the right because it's 1 and 7/500, and a percent is just another way to write per 100. So it'll be a 1, and the per 100 is 75 per cent per 100. All right, so that's that. And we're going to look at an example. So we're still on page number 45. You toss a coin 12 times to get 7 heads. Write a ratio of the number of heads to the number of tails. The main thing to keep in mind here is that order is important. So it says write the ratio of the number of heads to the number of tails. So whenever you get a ratio question, I want you to write the words first and then write the numbers. So it says the ratio of the number of heads, so I'm going to put heads, to, and then next we need tails. So it needs to go in that order. So we know that, so some given information that we know is that the coin was tossed 12 times. So total is 12. So that's the part and the whole of heads and tails. And then we know that the heads is 7. So if the heads is 7, how many times did it land on tails? That's the question. You can use subtraction because the part plus the part should give you the whole. So if it landed on heads 7 times, it had to land on tails how many times? 5 times. Because 7 plus 5 is 12. So if you put the heads and the tails together, it should total up to heads and tails together. So that's that. So this is going to be a part to part ratio. It's really important for you to know what type of ratios you're dealing with. A part to part ratio. So you know that you should not use the 12 because the 12 is the total times the coin was tossed, which includes heads and tails. So the number that we need to use to represent heads is going to be the 7. And then the number that we should use for tails is not the 12, but it should be the 5. Okay, what is another way to write this? So you can write it using a colon, 7 to 5. You can write it as a fraction, 7 over 5. You can write it as a decimal or a percent, but we're going to keep it moving.